Alright, today we're going to continue talking about right triangle trigonometry. We are going to be typing stuff in on the calculator, so you've got to make sure that you're in the correct mode. Alright, if you hit your mode key, which is right next to the yellow one, alright, if you have little circles, that means you're in degrees. If you have pies, that means you're in radians. So for these, I need to be in degrees, not radians. So you want to make sure degrees is black. And then you just type them in. Well, for sine, cosine, you have a sine key, a cosine key, and a tangent key. Above them you have, I don't see if you can read it, but that says sine to the negative first, cosine to the negative first, tan to the negative first. Those keys in yellow are inverse keys, not reciprocal keys. Remember, cosecant is not the inverse of sine, it's the reciprocal of sine. Those are not reciprocal keys. Do not touch them at this point. We won't need those keys for a while. What you have to know is how to type the reciprocals. Well, let's start with the ones that we don't. So cosine 30, make sure you're in degrees, and you type cosine 30 and you get 0.8660254. For some reason, they usually like to go out 4 places in trig. So my answer to 4 places would be 0.8660. Okay, tan 54. 1, 2, 3, 4. The 8 would bump that up, so I would say my answer is 1.3764. Now, cosecant. Cosecant is reciprocal to sine. So you can't use that inverse sign. That's not what that key means. So you're going to type 1 divided by sine of 45. Okay, because cosecant is reciprocal, which means 1 over. Flip it. Okay, so that's how you type it. 1 divided by sine 45, and 1, 2, 3, 4. The 1 won't do anything, so my answer will be 1.4142. And so since secant is reciprocal to cosine, you type 1 divided by cosine 25. Type that in, and 1, 2, 3, 4. The 7 will bump it up, will be 1.1034. Okay. Alright, so now we don't see the little circles, I see these pies, which means we're in radians. So you want to make sure that radians is black. And then again, to type in cotangent, we don't have a cotangent key, and we can't use inverse tan. That's not reciprocal. So to type cotangent, you type 1 divided by tan of pi divided by 8. Again, if you're in the right mode, you'll get the right answer. 1, 2, 3, 4. That's going to be 2.4142. Sine, I don't have to do any fancy keys. I just type sine of pi over 3. Make sure you're in radians. 1, 2, 3, 4 will be 0.8660. Cosecant is reciprocal to sine, so to type that one, you're going to do 1 divided by sine of pi over 6, and you get 2. Alright, so do this one. Hit pause. Come back when you're ready. And hopefully you got 0.24. I made sure I was in degrees, and then typed sine 14. They rounded to 2 places, so the 1 didn't bump it up. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got 5.76. Again, I got to make sure I'm in degrees. To type cosecant, it's 1 divided by sine. And they went out 2 places, so the 8 bumped it up to a 6. Okay, try this one. Hit pause. Come back when you're ready. Check your mode. And hopefully you got 2.08. If you didn't, I had to go back to radians. And I have to type cotangent as 1 divided by tan, pi over 7. They went out 2 places. The 6 bumped the 7 up to an 8. Alright, try this one. Hit pause. Come back when you're ready. And hopefully you got 0.38. I'm in radians. To type, I don't need to type anything fancy, just cosine 3 pi divided by 8. They went out 2 places. The 2 does not bump it up. Alright, so some applications. You need to draw a picture of the problem. And we've got to talk about angle of elevation and angle of depression. See this little guy standing here on his balcony? This horizontal is his horizontal line of sight, going straight from his eyeballs. If from that line of horizontal you have to look up to see something, that would be an angle of elevation. If you had to look down to see something, that would be an angle of depression. Okay? So it says, sitting at the top of a building, a survey measured the angle of elevation to be 22 degrees. The transit is 5 feet above the ground and 300 feet from the building. Find the building's height. All right, so we have this picture, all right, that they so nicely drew for us. And you got this guy sitting up here. Or, no, he's down here, but he's sighting the top of the building. And he found the angle of elevation to be 22 degrees. The transit is 5 feet above the ground, okay? So this transit is 5 feet off the ground, and it's 300 feet from the building. And they want us to figure out the building's height. All right, so from here, this would be my theta. I'm looking for opposite. I know adjacent. That would require using the tangent function. So I would say tangent of theta equals opposite over adjacent. And to solve for x, we know the angle is 22, sorry. To solve for x, I'm going to multiply both sides by 300. So if I type in 300 times tan 22, check your mode. I need to be in degrees. I almost messed up. Alright, so now I'm going to do 300 times tan of 22, and I get 121.21 equals x. So the height of the building is 121.21 feet. But that's not all the way to the ground. That's to the height of the transit. So to get the actual height of the building, I need to add that 5 feet back to it, which gives me 126.21 feet. Oops. Yes? Alright, so you try this one. Hit pause, come back when you're ready. And hopefully you got 12. They want you to find the measure of the side of the triangle whose length is designated by a lowercase letter. So they want me to find little a, which is opposite of the angle they gave me, and this is adjacent. So I'm going to use a tan function. So I'm going to say tan 33 equals opposite over adjacent. To get a alone, I'm going to multiply both sides by 19. And a equals, make sure you're in degrees, 19 times tan 33, and I get 12.33874427. They want the nearest whole number. 3 isn't going to bump it up, so it's 12. Alright, try this one. Hit pause. Come back when you're ready. Alright, and I tried to draw the picture for you. It says a surveyor is measuring the distance across a small lake. So we've got this lake and he's trying to measure this distance across. He set up his transit on one side of the lake that's 80 feet from a piling that's directly across from a pier on the other side of the lake. From his transit, the angle between the piling and the pier is 35 degrees. Angle between the piling and the pier. What is the distance between the piling and the pier to the nearest foot? So they're looking for this. So if I'm sitting up here, they want me to find opposite. They gave me adjacent, so that's tangent. So I'm going to set up tan 35 equals opposite over adjacent. So to get x alone, I'm going to multiply by 80. And I get x equals 80 times tan 35. And I get 56.016600306, which is approximately 56 feet. Okay. Alright. It says calculated keystrokes to solve for an angle. So now we're trying to figure out what theta is. We're not trying to figure out a missing side. We're trying to figure out what theta is. Okay, so now is when we're going to use those keys. Basically, if I'm trying to figure out what theta is, I need to kill sign. I need to get rid of sign. You know, just like if it was multiplication, we'd use division, so on and so forth. Well, now we're going to use those inverse keys. What kills sign is arc sign, or inverse sign, or sign to the negative first. It doesn't mean you're raising it to the negative first degree. That key means you're talking about the inverse function of sign. But you have to do it to both sides. All right, and if they ask you for in degrees, make sure your mode is in degrees, and then you're just going to type it in. Okay, so I arc sine both sides, and if I type it in the calculator, I'm going to hit the arc sine key, so you hit second sign, and then you type in 0.8910 and hit enter, and that gives me my theta is approximately, if we round to the nearest degree, that's going to be 63 degrees. Okay, so to kill cosine, we're going to use arc cosine on both sides, and to type that in, you do second cos, and this tells me that theta is approximately 85 degrees. All right, now this one, they want us to figure it out in radians. All right, so switch your mode back to radians, and to kill tan, you're going to use arctan on both sides, and you're going to type that in radians, and theta would equal approximately 1.05 radians. Yeah? All right, so you do this one, hit pause, come back when you're ready. And hopefully you got 60 degrees. Oops, let me back up. Sorry, I didn't type it in apparently. All right, so if you arc sine, and they want it in degrees, so check your mode. And so you would type, sorry, I had to check my mode. I would type second sine of 0.8659, and you get 59.9856329 to the nearest degree. It's going to bump that up to 60. All right, so try this one. Hit pause, come back when you're ready. I hope you checked your mode. They obviously want it in radians, so I'm going to have to switch my mode back to radians. But I'm still going to do arc cos, or second cosine, 0.2286, and you get theta equals 1.340156967, and they said to 3 places, 1, 2, 3, the one won't bump it up, so my theta is worth 1.34 radians. Alright, so this one says a building that is 21 meters tall, so the building is 21 meters high, casts a shadow. Shadows are on the ground, so the shadow is 25 meters long, and it says find the angle of elevation. So now I'm trying to figure out what this angle is. So I'm standing here, they give me opposite, they give me adjacent, so that's a tangent function. So I set up tan theta equals, sorry, there's a bug flying around me, opposite, which is 21, over adjacent, which is 25. And to kill tan, I'm going to arctan both sides. Now you got to make sure that you're back in degrees, because they said to the nearest degree, so I got to switch my calculator. Back to degrees, and then I'm going to hit second tan, and I'm going to just type 21 divided by 25, and I get theta equals approximately 40.03025927, which means it's approximately 40 degrees. Okay, you try this one, hit pause, come back when you're ready. Alright, it says a building that is 300 feet tall casts a 500-foot long shadow. If a person looks down from the top of the building, what is the measure of the angle between the end of the shadow and the vertical side of the building. The end of the shadow and the vertical, so they want this angle. Right? To the nearest degree. Assume the person's eyes are level with the top of the building. Oh, no. So the angle between the end of the shadow and so it's up here. Okay, so we're looking for that angle. So we're sitting on top of the building. So from that perspective, they give me opposite and adjacent. That's tangent again. So tan theta equals 500 over 300. To kill tan, I'm going to use an arctan. Make sure that you're in degrees. I'll check mine, yeah. So I'm going to second tan 500 divided by 300. And I get the wrong answer. So it'd be opposite and adjacent. A building 300 feet tall. Oh, good grief, that's a 50-foot shadow. Something. Oh, if you only read the problem, like I yell at you guys all the time to do. There we go. So that should only be 50 feet, not 300. So then you get the 9.462322208, which if you round to the nearest degree would be 9 degrees. Alright, so how do you use right triangle trig and the inverse trig functions to solve application problems? Well, again, if we were solving for theta, let's say you knew opposite and adjacent, you would say tan theta equals opposite over adjacent, and then you use your inverse trig function, so you would arctan to figure out what theta is. And you would use the inverse operation of opposite over adjacent to figure out your theta. Okay? And we're at homework, so we're done. Happy homeworking, and I'll see you next time.